Hey, Mr. Antonucci here, and in this video, we want to prove the formula for the volume of a right circular cone using calculus. So we're going to use circular cross sections to verify that the volume of a right circular cone having radius capital R and height h is 1/3 pi capital R squared h. So the first thing we do is simplify the mathematics of this by positioning the cone with its vertex at the origin and its axis on the x-axis, as you can see here. The cone extends from x equals 0 to x equals h. In a cross section of that cone right here, taken at some arbitrary x value inside the cone, the slice there is a circle of radius r. So also embedded in this picture, if you looked at it straight on, you would see a right triangle that actually has two similar right triangle, one with side x and height r, and the other with side h and height capital R. So as what we can do with these, since these are similar triangles, meaning they all have equal angles, the corresponding sides are going to be proportional to one another. So what we could do is take the ratio of r over x for the smaller triangle and say that's equal to capital R over h for the bigger triangle. Now, the nice thing about this is we can solve for r, little r, and get that in terms of x. Because remember, the capital R and the H are the actual dimensions of any cone. And we're going to try to do this specifically or in general so that we can get the volume formula for a cone. Now, that slice right there is circular. So the area of that slice taken at x is pi r squared. And remember, r is capital R over h times x squared. So that's going to give us pi capital R squared over h squared times x squared. And since this function a is a continuous function of x, remember x is where the slice was made, the volume of the right circular cone is given by integrating the area function over the interval. So if we go from 0, where the cone's tip is, the vertex, to h, where the cone kind of finishes, we can integrate the area function over that interval. So pi capital R squared over h squared x squared dx. And remember, pi, capital R, and h all represent constants. The variable here is x, and that's where you are slicing the cone, so to speak. So we could actually factor everything out except the x squared. So we have pi capital R squared over h squared times the integral dx. And we're integrating with respect to x. So you have pi r squared over h squared times 1/3 x cubed, the antiderivative of x squared. We're going to plug in 0 in h and then subtract. So if I factor all the constants out, I would have pi capital R squared over 3h squared times x cubed evaluated at h and 0. So you'd have h cubed minus 0 cubed. 0 cubed is 0. And the h is going to cancel with this h, giving you just h. So you would have pi over 3 capital R squared h, which is equal to the volume of a right cone. All right, guys, there you have it. The volume formula of a cone proved using calculus, and we learned that formula way back in geometry.